Hello, welcome to Quantitative Development Policy Analysis. This is the instructor of this course. My name is Ali Akemik. You can just call me Ali. And in this first lecture, I want to start with a brief self-introduction of mine and then continue with the rest of the course. I guess some of you already have taken my course, Industrial Policy, last semester. So you probably know a little bit about me. But for the benefit of everyone here, I want to start with a very short, brief introduction. I am from Turkey. I have graduated from the Middle East Technical University in Ankara in 1999 with a degree in economics. Then came to Japan, just like you, to study at Chiba University for a master's degree and at Nagoya University for a PhD degree. I got my PhD from Nagoya in 2006. After that, after the military service, which is compulsory in Turkey, I worked in two universities in Ankara and Istanbul, and I taught economics for 10 years. In 2007 September, I came to Yamaguchi and joined the Faculty of Economics. Since then, I have been teaching at the Master's in Public Administration program, basically industrial policy. So this is my second course I offer in this program, Quantitative Development Policy Analysis, starting from this semester. You're my first guest, so please enjoy the class. It is a thorny road, but at the end, I think you will like the outcome. You will like what you have learned. So you're gonna love it. Without much further ado, I want to start right away with the outline and continue. This is the outline of the first lecture. At the beginning, we will start with a description and interpretation of what we call the circular flow diagram, which is the easiest way uh, to overlook the transactions in an economy. And then I want to spend some time on why CG models are so popular, at least for some economists. What are the merits of CG models? Of course, I have to also talk about shortcomings of the model. And then I want to spend some time on some background about the data which are required when running CG models and building CG models. So CG model is a numerical model, and the numerical model requires a data set, and these two data sets are, first of all, input-output tables, and then building on input-output tables, the social accounting matrix. The social accounting matrix is the numerical version of the circular flow diagram. So we have to know about these two data sets before we start CG. So this first lecture will be focusing on the social accounting matrix, which we will shorten as SAM. So I want to start with the circular flow diagram in the next slide. At the outset, the starting point for a CG model is the circular flow diagram. The circular flow diagram is the first thing you learn in an economics introduction to economics course. They usually teach this in the first week of the first year students in Department of Economics, universities around the world. So let us now focus on a closed economy. A closed economy is one which is not exporting, importing. And here is a figure from Ian Soo Wing's paper, which I just copied from there. This figure shows the circular flow diagram of commodities in a closed economy. As you see here, we have three actors. Okay, so these are households, government, and firms. Households here are functioning in a way that They are the owners of the factors of production. The factors of production in economics are the resources we use in production, which are basically labor and capital. So basically, these households can be entrepreneurs who are owning firms, or they can be workers providing their labor services. Um, okay, so this is one of the actors in this economy, households. And then there are firms. The firms are renting the factors of production from households. So basically, if they are managers, they are providing their services to firms. If they are workers, they are households. They are providing their labor services in the production process. Of course, the main task of a firm in the economy is production. So the firms are producing goods and services, and these goods and services are then sold to households, which are consuming them. And then there's the government. The government is right in the middle, uh, sometimes providing goods and services in the form of, public goods most often, and also receiving taxes from both households and firms. From households in the form of income taxes or direct taxes, and from the firms in the form of corporate taxes and other forms of indirect taxes. Notice that the government also can make transfers to both firms and households in the form of subsidies or health related, social safety related transfers to households. So this circular flow diagram, you can see arrows with straight lines and dashed lines. If you look at the straight lines, you will see how the commodities are actually circulating in an economy. Firms are producing goods and services, and this is the upper part of the circular flow diagram, um, to households. These goods and services produced by firms are sold to households in the product markets. You can also call it goods and services markets if you wish. So this is the market economy, and the relation between firms and households is happening in the product market. And then continuing from the household, which is on the left side of the circular flow diagram here, from households to firms, if you look at the straight line, you will see that factor inputs are flowing from households to firms. Factor inputs, as we mentioned before, it's capital and labor. So households are providing their capital and labor services to firms, and this is happening in factor markets, or you can just call it factors of production markets. This is basically what's happening in the physical world. So products are flowing from firms to households, and then from households to firms. Factors of production are flowing. The economy is also running, and also there's another straight line from government to firms. If you see that government is providing goods and services to both households and firms. Government is also a producer in an economy, not a major one maybe, but government is producing a lot of services ranging from education and health to even in some countries some basic necessities in factories. So in developing countries where we most of us are coming from, the governments can have a very important role in the economy. Well, the importance of the government depends on the numbers, which we don't see here. But this is basically a description of the a general outlook of the economy. Okay, if you look carefully, you will see also dashed lines. The dashed lines is the other side of the circular flow diagram. This is the monetary world. So firms, if you look at the dash line running from firms to households, it says profits and factory income. So in return for their distribution of their services to firms, households are receiving um, payment from firms. So when they work as a worker, they get wages. And when they provide their managerial services like a CEO or some other professional, they receive a share of profits for their services. So if the household itself is a owner, also all of the profits goes to the households. For example, if you look at small ramen shops, if you like ramen, you will easily recognize that a small ramen shop, a noodle shop in Japan, very popular. You see, you will see that there's a one owner and maybe one or two family workers probably, and probably a student working part time. If in the case of such a ramen shop, restaurant, small restaurant, the owner receives profits, and the part-time worker, the student, he receives a wage. So this is what happens from firms to households. In return of the delivery of services, households, because they are consuming these services and goods from firms, produced by firms, households are paying firms the price of the goods and services. This is expenditure, and you can see it, the dash line in the upper part. Okay, um, so this is how the money flows in an economy. You can resemble money. Uh, it's something like blood in human body. Okay, so and to complete the picture, you can look at the the government, the relation between government and firms on the monetary side. Households and firms are paying taxes to the government. Okay, these taxes are used by the government to provide the goods and services, and also transfers to both households and firms in the form of subsidies and lump sum transfers. Okay, these are the budgetary rules for the of the government. So what you see here is a closed economy. In an open economy, we have on top of all these, we have a foreign sector. We will see that in the next slide. Here's another circular flow diagram, but this time for an open economy. I took this diagram from Wikipedia, and this figure is not copyrighted, so we can safely use it in our lecture. On top of this graph, you see overseas sector, which is the foreign sector, and the rest of the circular flow diagram looks very much like what we have seen in the previous slide, with that additional financial market. As you see, we were in the previous slide, there was only one market. Now there were only actually two markets for the factors of production, which is at the bottom in this graph, and then there was another market for goods and services, where goods and services were sold, and in the market for factors of production, capital and labor, which are the production factors, were traded. And now in this circular flow diagram, most often they, just like in this circular flow diagram, most often they also include a financial market. Financial market is a bit different kind of market compared to market for goods and services and markets of factors of production, because uh, only financial capital is traded in these markets. So what happens is when households, firms, and government, when they uh, save, like households are saving out of their budget, governments are saving out of their, government also has public budget. So when the government is having a surplus, it is public saving, and then when firms, enterprises are saving out of their budgets, these savings go to the financial markets, and the financial market acts as an intermediary by pooling all these available funds which are coming from the savings of these actors, households, firms, and government, and then channeling these funds to investments. And these investments are realized by firms and sometimes by government. Okay, uh, what we see here is also is a bit more complicated than the previous circular flow diagram. You can see that the government is now also engaging in consumption, the government expenditures. Government is purchasing goods and services from firms in the goods and services market. Okay, at the top you see overseas sector. Overseas sector. The overseas sector's role is exports and imports. This is happening in the market for goods and services again, and the exports are the domestic economy's sales to the foreign sector, and then imports are purchases of the domestic residents from overseas sector, which is a foreign sector. So far we have seen a very simple description of what's going on in an economy at the macro level. Okay, so this is a very nice picture, but what we do in CGE modeling is to put these into numbers and make it a bit more complicated so that it will serve our needs of policy analysis. So basically, what we will do in the rest of the course is, okay, remember this diagram very well. What we will do in the rest of the course is to model this economy, the same picture you see in this slide, and put it into a model which will work with numbers, and this will be a very consistent model in itself. It will work like a machine, and we will be working with this machine by providing our inputs, which is our numbers, and then we will be running this machine, which means we will be investigating how the economy is working, and then we will work with some policy simulation. So we will give shocks to the economy and see the output, which is in other terms policy or impact analysis. Okay, so I want to finish the discussion about the circular flow diagram here. If you're interested, there are a lot of other materials about circular flow diagram, in even in introductory textbooks. Please refer to such texts. But I want to make something clear at this stage, which is about budget and expenditures. So we have now settled how to view the flow of goods and flow of money, or flow of funds, in other words, in a simple economic structure. But we didn't say much about the use of budgets and expenditures. This system looks like what the physicists, the scientists, think about the universe. So in the universe, there's this famous theory of the conservation of energy. So in this model, basically these kind of models have been developed by natural scientists. One of the first modelers in economics is Alfred Marshall and Irving Fisher in the late 19th, early 20th centuries. And these people, Irving Fisher, not surprisingly, he has a degree in physics, but he is regarded as one of the greatest economists in the first half of the 20th century. Okay, here you see a similar view of the economy. not the universe, but the economy. And basically, both value and product are actually conserved in this picture, and the whole system works on an equilibrium. Okay, so let me just talk a little about what we mean by that. In this circular flow diagram, or in this economy, whatever is produced by firms, it is completely consumed by households, firms, or government. Uh, and when value is created, it is also entirely distributed by these among these actors. There's no leakage, and everything is working perfectly. So the sum of all expenditures in this system must be equal to the sum of all incomes. Uh, well, basically, this is what we also mean by GDP, as you know. Um, so, in other words, it's like shopping. So, when you go shopping, for example, in a supermarket, you pay for what you buy, right? So, your expenditure is the the supermarket's income. So, an expenditure for you is an income for the others. So, the sum of all expenditures must be equal to, or in other words, must be balanced by the sum of incomes. So every expenditure is spent, every expenditure spent on a commodity is actually a revenue for those who are producing that. That means value in this system uh, cannot be coming from just nowhere, and also it cannot disappear. So when you are making a purchase, basically you're transferring your purchasing power, and in return you are receiving a good or service. So this is what we mean by circular flow, because it's a circular flow. There's a flow, right? And this circular flow is named after all this what we call a perfect system of material balance. Okay, in this material balance system, or the circular flow diagram as we name it, there's also something which is very important about budgets and expenditures. So all these items here, all these actors here, households, governments, and firms, even foreigners, they have a budget, and they are using their budget in a way that, for example, if you look at households, in households, okay, you are households too, you can understand it very well. The households are basically using their budget. Their budget is made up of revenues or income coming from the factors of production which they are selling to firms. So this is profits and wages that they earn in return for their services. So this budget, uh, household budget, is spent on production of goods and consumption of goods and services, which might be coming from either government or firms, or from the foreigners in the form of imports. So households are spending their income on purchasing of goods and services, plus they are paying tax to the government, and then remember they may be saving. So this is how they are allocating their budgets. A similar story for government. Government also has budget. The budget, the revenues, the income of the government is coming from either sales of goods and services to households and firms, or taxes from these households and firms. And then this budget is allocated to purchases of goods and services from firms, or even from outside, from the rest of the world, which is from which are imports, and the government may be making transfers to firms and households from its budget, and finally the government may also be running a surplus, which is a public saving. Okay, so but the governments most often are running a deficit. That means the negative saving. Okay, and the negative saving means that the government is borrowing. The government may be borrowing from the financial market, or the government may be borrowing from, of course, if possible, from the rest of the world. Here you see overseas sector or foreign sector, but in the CG models in SAM, we will see later on, we name the foreign sector the rest of the world, or ROW, in short. Okay, finally for firms. Firms are receiving their revenues, income from sales of goods and services, and they are making payments. Okay, this is what makes their budget, and then they are using these revenues or this budget to purchase factors of production from households, which is payments to labor and capital, and then they may be importing from so they may be importing from the rest of the world. By the way, when the firms are receiving income, this income is coming through the market for goods and services, not only from government and households, because the firms are producing goods and services, and they are selling these goods and services to government, households, and also to the foreigners. So exports are also a revenue item for firms. Okay, then the firms are allocating this budget to purchase factors of production from households, and they are paying tax to the government, and they may be importing from the rest of the world. And also, don't forget that the firms are also investing, which is another expenditure item. Investment is is an expenditure, but investment is for future production. So firms are usually expanding their production capacity through investments. Okay, finally, the firms might be borrowing from the financial markets for investment. Okay, this is basically what a circular flow diagram tells us. As you see, it is a perfect system where every interrelation or every relation between every actor here is recorded and also working smoothly. So this is the general equilibrium, as we name it. And computable general equilibrium is the computed version or the numerical version of this equilibrium, or just the circular flow diagram. So one final note about this circular flow diagram is that, well, based on economic theory, all the sum of all the revenues from the production of goods is then distributed to households in the form of wages and profits, and also to other industries. Okay, well, when one firm is buying another from another firm, it basically uses it as an input. Okay, and then the inputs are used in the production of other products. And also, don't forget that part of the receipts of from the sales of these production of goods and services is also paid to the government as taxes. This last sentence I just mentioned actually is it brings forth a very important identity in economics. Actually, I'm sure you already have learned about this in introductory economics courses, but this is about how we measure value in in an economy. The value of a product or good and service is equal to the cost of all the inputs we use to produce it, plus the payments we make to the factors of production when producing those goods and services, which is wages and profits. So this is what we call a zero profit assumption in macroeconomics. That is to say, the value of a product is distributed completely uh, among intermediate inputs, okay, inputs used in the production, wages and profits. Wages goes to workers. Wages go to workers. Profits go to uh, owners of the firm, and input payment to inputs goes to other firms. So basically, there's nothing left, and if anything is if there is any surplus on top of these, and this makes a profit, but we assume there is no profit in this case. So zero profit assumption is the essence of microeconomics, and also this is as you will remember, this is what happens in a perfectly competitive economy. So the last thing to say about the circular flow diagram is that the circular flow diagram depicts a general equilibrium, or the equilibrium in an economy where there's perfectly competitive markets producing commodities and making zero profits. Okay, this is very, very important. And making zero profits actually is also what is required as the conservation of product or conservation of value requirement. So to just clarify, we will just assume that the markets are clearing. The markets are perfectly competitive and the firms are making zero profits. If you want to learn more about this, please refer to the perfectly competitive market and their main features in an introductory economics textbook. So let's continue with the next slide. Okay, so having said much about the circle flow diagram, let's look at why CGE model. Okay, why do we need a CGE model? First of all, CGE stands for Computable General Equilibrium Model. So general equilibrium is what we just saw in the previous two slides. It is the circular flow diagram. Uh, as you see, in a general equilibrium, we want to ensure that the transactions, the relations between all economic actors are in our hand and we are recording it. And then the CG is computable, which is, as you will see later in this lecture, that we are using with numbers and we are using with uh, a model to work with. So it is a model, and don't forget, the models have certain techniques. And in this course, we will be using GAMS software, General Algebraic Modeling System software. Okay, we will be doing some programming with that, although it is simple. It might take some time for those who are not very comfortable with computers, but I don't think it will be difficult for you. So remember that modeling usually works on a step-by-step basis, and we will be learning about each step later on. Okay, so it's too early to talk about that. So let me just focus our attention on CG model. Well, as we just mentioned, CG is about this circular flow diagram, and CG is basically about all transactions in the economy among all economic actors, firms, households, foreigners, government, and with all their interdependencies, which is production, investment, export, import, taxes, transfers, etc. So the beauty of the CG model is that you can give shocks into this model and you can see the results. That's why these models are very popular in uh, in the policy impact analysis. In most economic analysis, actually in most papers published in the field of economics, you will see that they are either microeconomics or macroeconomics. Microeconomics papers are very complicated, using a lot of mathematical tools. Macroeconomic models are, or macro policy models are, well, basically, you know about aggregate demand, aggregate supply, monetary policy, fiscal policy. These are all very important, of course, and I would say 95% of the economists are using these tools. So the remaining 5%, minority, including me, myself, we are using. I'm also doing such research too. I'm also using macroeconomic models, and I'm doing macro studies as well. I published in using those tools as well. So uh, this is fashionable. So a lot of people are doing this. Macro policies and macroeconomic studies are very important. There's no doubt about that. But I believe, and this is why I opened this course, I believe that especially for developing countries like our countries, I'm coming from Turkey. Some of you guys are from Nepal, Laos, Bangladesh, China. So, Capo Verde, right? Indonesia. So, Vietnam. These countries, for these countries, I believe the economic structure is also very important, because most of the economic theories are originating from economists coming from developed, advanced economies, right? The way their economies are structured and the way the developing countries are structured is different. So, for this reason, I think that a more consistent and maybe more reliable modeling technique using economic structures and their differences, maybe across countries, would be more appropriate. So, the beauty of a computable general equilibrium model is that it is based on what we call input-output tables, which we will see later on. And the input-output tables show us the linkages between different sectors in an economy. Okay, so this might be very important for countries at the early stage of development, because sometimes you want to know what industry is affecting what other industry, and this might have some implications for development policy or economic development trajectory. And sometimes actually these linkages and anything that might affect the structure of an economy, or that might induce a structural change in a developing economy, these linkages and these structural changes might be even much more important than a macroeconomic policy, fiscal policy, or monetary policy. Okay, so fiscal policy, monetary policy are macroeconomic models, but they don't say much about which sector in an economy is affected by how much. And the CG model, because of the database it is using, input output data, social accounting metrics it is using, it has a lot more to say about such issues. Or, in other words, I would say interactions, not only among actors in an economy like this, in the circular flow diagram. In the circular flow diagram, you remember firms. Firms actually mean industries too. So you can make it more complicated. So rather than working with just the one type of a sector, you may have, say, 100, 200 sectors. So you can easily um, trace the interactions, the relations, the linkages between these sectors through a CG model. So when you give a shock to the economy, say, for example, if you want to know What happens if the government increases subsidies to electronics producers in Vietnam, for example? And if you want to know what the impact it might have on agriculture or it might have on automotive sector or whatever industry you're interested in, you will get the results from a CG model and you will get a numerical result, a number with either a negative or positive sign attached to it. Maybe at this point, because it is related with macro policy per se, I must admit maybe a shortcoming of a CG model. As you see in the previous two slides, in the circular flow diagram, um, you don't see anything. Although we were talking about financial markets, you don't really see money itself. Money is very important in macroeconomics because um, in macroeconomics you see that there's the problem of inflation, and inflation might be very important for macro policy making. So CG models, um, as you see, it is a perfect system working, and what you see in the circular flow diagram is something like a barter. So you are exchanging in this barter system. Barter means, exchanging one product with another product, not money. So the whole system in the circular flow diagram looks like a barter. And these are the straight, solid lines in the first circular flow diagram, the closed economy one. You will remember that. That means we are not actually tracing or keeping track of any financial sort of transfer in this model. So what I'm trying to say is CG models, we do not take money as a commodity. And in macroeconomics, money is a commodity. You can buy money for its value, but in a CG model, it doesn't happen. CG model is more like a real economy kind of model. Real economy meaning you are working with physical products, but money is not treated as a physical product. So because we are not treating money as a commodity, the whole system, the general equilibrium system um, in the circular flow diagram, when we turn it into a modeling system in CGE, because we will not be using money because as a commodity, um, what we will do is we will take one product and we will call it a numeraire, and the numeraire means a benchmark good, and we will be calculating the value or the price of every product in the CG model with respect to or relative to that product. Okay, so basically we will be taking one product, okay, and then we will just fix its price, and we will calculate the price of every other product in this economy in the CG model um, relative to that product. Okay, so basically we will be solving for relative prices, not nominal prices. So nominal prices are the prices you see in supermarkets, the tags on the shelves. That's the nominal price. But CG model doesn't work that way. Okay, maybe it's too early to talk about this at this stage, but I want you to know that CG model will solve for relative prices, which we will be elaborating on that later on, and we will not be dealing with money. That means we will not be talking about inflation. If you really are interested in inflation as a policymaker, CG models are not what you need. Basically, you will be needing a macroeconomic model. I mean, aggregate demand, aggregate supply, ISLM or MP. Recently, it's called MP kind of model. So, if you want to do a research on, say, inflation targeting, CG policy is not what you need. Okay, so we will be talking about this when we elaborate on the algebra behind the CG model and the social accounting matrix. So let's continue with the CG model and its features. Okay, you might want to know what merits CG has over other methods you might use in your research. For example, demand supply, simple demand supply analysis, or econometrics. Um, well, we call demand supply equilibrium partial equilibrium. So partial equilibrium means we are not considering anything else but only a part of the economic system. So if you remember demand supply graphs, there's on the horizontal axis there is quantity Q, and on the vertical axis there's price. There's a demand curve which is downward sloping, and then there's a supply curve which is upward sloping, and then there's a intersection, and the intersection is called equilibrium. But if you remember, this is so demand supply graph or demand supply curves of, for example, the tea market, for example. It is the price of tea and quantity of tea, but nothing else. So because the prices and quantities in all other sectors are not included in this demand supply equilibrium, plus incomes of households or any other variable which might actually affect demand supply equilibrium are not even in the demand supply graphs. So this equilibrium or this as you will remember, the demand supply equilibrium graph doesn't take into account any of this, but it only takes into account the price of tea and quantity of tea. That's it, nothing else. So everything else is fixed. And if you remember in economics, we call it ceteris paribus. So everything else is unchanged. So CG is different because, as you remember, CG model takes into account everything in an economy. So partial equilibrium doesn't do that. And in a partial equilibrium model, just like demand supply, when you give a shock to the equilibrium or to the model, what you see is what a change, right? Price might be changing, and quantity might be changing. But what triggers this change is the price. So when the price changes, demand and supply, or quantity demanded, quantity supplied, are adjusted. But as you know, we were saying that income and the prices of other products are kept constant. So because of the ceteris paribus assumption, everything else, all the resources, uh, all incomes are constant. This is not realistic. Well, demand and supply analysis might be working to understand the what's going on in certain sectors, which may be useful. But for a general equilibrium point of view, they're not really realistic. So okay, let's just assume that there's this equilibrium in the demand supply of tea market. Okay, so when you give a shock, there's a price change in the tea market, the price of tea changes, assuming that there is no income effect. It is not really realistic. So when the price of tea increases, for example, that means the revenues of tea producers will be increasing. And on the other side, if you're a consumer of tea, you will feel like you can buy only less amount of a smaller amount of tea compared to the case before the shock. So you will be, and if tea is very important for you, then you will think that you have a negative income effect in this case. So your welfare is negatively affected, and if you're a consumer. Okay, so basically income, prices, wage. So by income, I mean incomes are coming from wages and profits and things like that. So these are all interdependent. So When we say interdependent in modeling terms, we mean they are endogenously determined. So the model should actually solve for incomes and for everything for everything that price changes might affect. Okay, and incomes might be determining expenditures, which is demand, right? So when the producers of tea are earning more revenues because of increasing tea prices, in this case, well, they will be using this revenue to to buy other products. Okay, so which stimulates production in other sectors. Okay, and then income in those other sectors will be increasing, and then those incomes will be spent on other goods. Okay, so there's this multiplier effect, and this is not captured in partial equilibrium model, but the CG model takes into account such effects through linkages across sectors and through the interrelations between incomes, expenditures, and as part of a shock given to the economy. So this is one difference between CG and partial equilibrium. So we say CG is superior to partial equilibrium. So you might wonder, so is partial equilibrium all bad? Actually, it is not. So in some cases, partial equilibrium might be the right tool to use. Of course, this is the case if you're interested only in a specific sector but not other sectors. For example, if you're doing research on tea market, if you're interested in only tea market but nothing else, then what happens in other markets may not be of interest to you. So you may justify your use of partial equilibrium. And when using partial equilibrium, most often we use econometrics. Okay, so um, and partial equilibrium also might be justified or might be appropriate when um, the shock given in a sector actually does not really yield significant price changes in other sectors. So, well, actually, if you know about economics, microeconomics, you will just understand that when I say prices are not changing, we call it perfectly price elastic demand or supply. So perfectly price elastic demand is a flat demand curve. Perfectly price elastic supply curve is a flat horizontal supply curve. Well, this kind of demand or supply curves, if they exist, then you may say, well, partial equilibrium is what you need. Okay, but if you're interested in what's going on in other sectors, you definitely need a, CG model. And your choice between partial equilibrium and general equilibrium depends on uh, whether you're interested in uh, just sectoral policies in only one sector, or but not in others, or changes in one sector but not in others, and whether the price elasticity is high, which means if the price in a sector is not really changing prices in other sectors. If you're interested, here's a table uh, specifying the differences between econometrics and CG modeling. In econometric modeling, we use regression analysis, but in CG, we use a numerical model. In econometrics, we use a huge amount of data. The data requirements are high. Usually, you need a lot of observations if you want to get reliable results. But for CGE, well, it depends on how complicated you want your model to be. If you want a very complicated model, say, for example, 200 sectors, well, then you need more data. But your homeworks or end term project papers, you will need one or two sectors only, so the data requirement will not be very high. In fact, I will also be providing the data to you, this social accounting matrix. Um, So the data requirement will be very low for you. Okay, and for econometrics, if you're doing time series analysis, well, the time dimension has to be very long. And some of you are working on time series, I know, but when the time series are short, then you cannot use time series econometric methods. For CGE, on the other hand, we use data only for 1 year. We will call it the benchmark year. So any simulation, any policy analysis, we will be basing on the benchmark data. Okay, so another thing about econometrics is there's so many models that you have to choose from, and you may not be an expert on choosing the best model. And in this case, choosing the right model might be a really big problem. So sometimes econometrics is really a econometric models are like a pain in the neck. But CG models, you will see that most of them really look alike. Most features of the CG models are standard. So at the end of the course, if you give yourself to this course, you will learn the structure of a standard CG model. And if you look at the other CG models, if they provide the programming code, you will see that the standard CG model, the programming code of your CG model will look very much like other CG models. So that means you can actually modify your if you understand the modeling code very well, then you can modify your model to look like other models, and maybe you might want to maybe just adjust your model for different purposes, or you might use other people's model codes to maybe fit your own research or your own analysis. So this is possible because the models will be using standard features. Okay, and then in econometrics, you will need diagnostic tests. So when you're running a regression, you will get results, but then you will have to test so many things for reliability, for robustness. Um, okay, so robustness tests are in econometrics are troublesome and very tedious, but for CG, it's very easy. We will learn later on. This is the essence of modeling actually. When you run your model, it can be econometric model, it can be CG model. At the end, you have to test robustness. You have to change some things in your model just to see whether your model is really reliable. The results are really reliable. So in econometrics, you might want to use different forms for your variables or different kinds of uh, running your econometric methods. But for CG, changing some parameters or some fixed coefficients in a way will be enough. And if the changes and the uh, results are not large, you will see that your results are robust. Okay, and for another thing about econometrics is that they are not really effective in estimating welfare, but CG is very powerful. We will see later on. So let's wait until we discuss welfare change in CG. And welfare change is very important because the ultimate objective of any policy is to increase the welfare of the society. So econometrics isn't really doing a good job in that sense, but CG is very powerful. And finally, econometrics doesn't necessarily have to follow economic theory. You can just put a lot of variables in a regression and see what happens. And you don't need any theory sometimes. So you just may uh, just randomly put so many things, try many different models with different combination of variables you have, and just report the results which you like. But you don't have that freedom in CGE, because CGE, we will also see later on, um, because we have to also brush up our knowledge of economic theory too. CG depends on economic theory. So basically, we are using the circular flow diagram, but when we model, when we work on the algebraic form of the CG model, you will see that it completely depends on economic theory. So basically, CG is a bridge between your textbook, economics textbook, and the real world. So the bridge itself is the CG with numbers and the model. Okay, so let's move on. Here I'm trying to draw a very nice picture for CGE, just like a commercial. But I had to say that CG also is not perfect, and CG comes with its shortcomings as well. Well, one thing is that well, CG is a perfect model because it's consistent. It is a very well working machine. For example, we were just talking about conservation of value. Just like how the physicists view the universe. There's this consistency with that expenditures cannot be more than incomes; they have to be equal, and this perfect flow of goods and perfect flow of payments and expenditures, and a very nice equilibrium between all these. So conceptually, this is great, and this is consistent. We will just name it the law of Walras. So Leon Walras, uh, actually it is Walras. This is his name, but he's French, so they don't pronounce the last S in the end of his name. So Walras. So Leon Walras is a great economist, a classical economist in the late 19th century. What we just said about the conservation of value is coming from his idea. Okay, so basically what he says is zero profit. Every budget is perfectly distributed, and supply equals demand in an economy, right? So that's why CG is perfect, conceptually perfect, and we will see that also, because as a computable model, as a numerical model, it is also perfect. Uh, but as I said, it comes with its own shortcomings as well. For example, we will see later on. I'm sure you're going to ask me this question when we talk about parameters or elasticities, which we will be discussing in the coming weeks. You will just ask me this question, so I am sure that this is one of the questions I will get from you. But how do we know that it is 2? How do we know it is 4? Basically, I will just tell you then that we don't know. Let's just take it as 2. Let's just take it as 4. Let's just take it as 0.5 or something. We set it, right? Okay, sometimes we can estimate them using econometric methods. Uh, well, the beautiful part of CG model is that once we have your parameters or elasticities, these are some coefficients which we use in our equations in the model. Um, when you set them, the model will find a way to run itself, right? So sometimes it is not a big issue. And as I said, the CG model at the end, we will do robustness, so we can change these parameters. But changing these parameters, changing these elasticities, changing the parameters, they all have a meaning. For example, if you increase elasticity from 0.5 to 1.5, it is a big change. So 0.5 means a low elasticity, which means a quantity. For example, in microeconomics, 0.5 and 1.5, and elasticity for demand, for example, means that if something has an elasticity of 0.5, then quantity or consumption of people who are using it is not very responsive to changes in prices. But 1.5 is huge. So compared to zero point 0.5, then the response to a change in price is large. Okay, for example, zero point 0.5 might be the response of a very rich person's uh, a very very rich person's response to changes in, say, airplane tickets, air tickets. So because he's very rich, he doesn't care much about if the air ticket increases from say say $500 to $700. He's okay. He's fine. But for an economy class ticket holder or purchaser, that this might be a huge change in price. So he or she might even change his decision about whether or not buying the ticket. Okay, so basically, so this is what we mean by elasticity. But for CG parameters, elasticity is we set it exogenously, which means we just use it from out, we just give it from outside. The model doesn't solve this. Okay, so some of the numbers in CG models that we will see are exogenous, which means we just assume that they take that value, and we may be wrong, but the model will still solve itself. If you're wrong, then your job is to find the right number. All right. So at the beginning in our class, we will just, because we were dealing with a hypothetical economy, we will just determine them randomly. All right. And then the model, as I said, will just solve anyway. We call it calibration. Okay, so more to be said about this later. And then when we choose different values for different parameters, elasticities, the values will be different. But that is also another kind of analysis we do in CG models. And elasticity parameters are usually we usually need these to teach the model how to behave. Okay, if you're talking about firms, if you're talking about consumers, elasticity means how they are behaving. Just like how the first class, business class ticket and ticket purchaser and economic class ticket purchaser is behaving. Okay, having said that, uh, there's also another issue about CG modeling. We will be modeling production. We will be modeling welfare, utility, and such things. These are things you remember from your economics textbooks. And well, basically, there are so many functional forms. For example, if you're talking about production, there are many production functions, like constant elasticity, Cobb-Douglas. We will talk about this later briefly, and don't get distracted with the name of these functions, but we will be talking about them later. So you can choose between different functions for the same purpose to model the same thing. Well, it depends on what you want to do. It depends on, well, it's your taste. If you like one model, one function over the others, you can pick that. But we will talk more about this later. Okay, and I think I mentioned about this before. CG doesn't calculate prices, so we don't talk about inflation, monetary fiscal policy. So this is out of our scope, beyond the scope of CG models. Don't expect anything about this. Um, and maybe the last thing about CG shortcoming is that you will you will easily recognize that if you look at the literature, if you look at the papers written in economic literature nowadays, very few people are actually using CG models. Well, one reason is because you need some knowledge of programming. Okay, most papers you see, um, if they are not using very complicated and very recent, up-to-date econometric methods, they are using this statistical software like Stata or SPSS or things like that. And all you do in such a software is you're just using the menu. You're just putting your numbers, you're putting your variables, you just put your data in it, and then you just use the menu, and you get the results right away in 5 seconds, right? Um, but for CG, you have to write your own model. You have to program it, unlike all econometrics papers. So if you're doing your research using econometrics, you will probably not be you will not find it difficult to run your econometric model because you will not be writing a programming code unless it is something completely new. But only very few people do that. So most people I know, they're using this specific specialized econometric software. I myself am using Stata 2 for some of my research papers, and these are very user friendly. I like them. But for CG, you really need programming knowledge. So this is one reason why you don't see many people using CG models. Well, isn't that a privilege? You're welcome to the club. It is still too early to talk about the algebraic part of the CG model, and this slide shows what the CG model does. But let me tell you before I talk about this graph here, which I uh, borrowed from a very popular uh, article about how to uh, build a standard CG model uh, by IFPRI in Washington, D.C. IFPRI here stands for International Food Policy Research Institute, and they are using CG models extensively, very heavily in their research. Um and if you're interested, their homepage, their website, includes a lot of materials about CG modeling, plus a lot of data for different countries. As you know, we will be using SAM, Social Accounting Matrix, which is the main data set used for CG models. And they might have the most recent up-to-date data for your country as well. So just check it. And as far as I know, they are distributing all this data freely, uh, um, just on the condition that you use it only for research purposes. Okay, so before we discuss about this slide, okay, let me just tell you what we do basically in CG. What steps do we follow? But first of all, before you do anything, and this is what we're going to do from starting from the next slide. Uh, the first thing we need in CG model is the basic data. The basic data are two kinds: input output and social accounting matrix. Uh, Social accounting matrix SAM is the extended version of the input output table. Okay, once we have our data, um, we want to check that our data is correct. There's no problem with that. Okay, this is the second step. After that, we start at the same time. Actually, we start programming our CG model. I mean, all the equations, which you saw in chapter 2 of the textbook. Um, well, first of all, were probably a bit distracted about that, but that's what we're going to model in our software GAMS. Okay, once we have our model and once we make sure that the model works perfectly with no errors, we will put the data, which is the social accounting matrix. We will put the data into the model, or in other words, we will ask our model to read the data from the social accounting matrix. and we will replicate our model, because the original model is just equations, and the original model is basically how the machine works. Now we have to feed the machine with data. The feeding the machine with data means that we are with the CGE programming code that we're going to write. It's going to be a short model for us. It's a short code for us. Well, the let's see. So the model will be about the circular flow diagram, right? So we will be modeling the circular flow diagram, and then in this stage we will give our data. Okay, we will give our data to the model. We will call and we will ask the model using the data to replicate itself. The model that we're going to write the programming code about is about how the economy behaves or how the actors behave. The same thing, nothing different. That households are going to take income, spending on goods and services, paying taxes to government. We will be modeling only this. Okay, and then based on the same circular flow diagram, now that we have real world data, we will inject the data into the model, and we will ask the model to run itself. And then if the model runs itself with no problem, we will just say that the model calibrated itself. Okay, and then um, this is called replication check, basically. All right, when we find no problem, when we verify that the model replicates itself, it works, then we will just say that we found equilibrium. And the data coming from the SEM belongs to 1 year, which we will call benchmark year. So we will call this equilibrium we're talking about benchmark equilibrium. For example, if you have data for 2018, and if your data works with your model, you will just say that you found the equilibrium for 2018. Anything you want to do will be based on that equilibrium. Okay, for example, you might want to give a shock. For example, you decrease the subsidies to households, poor rural households, for example. If you want to know what happens in 20 years, because you can also run such models for 20 years and see the results after 20 years. Okay, so we will call it a shock or a simulation. After you find equilibrium, you run the simulation, right? You can run simulations in very, very different forms. We will be discussing that later. Okay, and then the results will be reported by our software, and we will just call it the new equilibrium. We'll find a new equilibrium after we run the simulation. Okay, the new equilibrium will be compared with the original equilibrium. Okay, the benchmark equilibrium. All the changes will be what we were looking for, right? When you give a shock to the economy, you want to see the changes, and these changes will be because of the policy. Okay, that is policy analysis or impact analysis. Well, that's how CGE model will work. When we program our CGE model on our software GAMS, this is what we're going to do. You see here in squares some variables and some arrows with something written on like CES, CET, CES. So CES and CET, you see they refer to elasticity of substitution as a transformation. We will talk about this later. These are the functions that we're talking about. For example, if you look at the left upper left part, you see the commodity of output from activity 1, commodity of output from activity n. So all these commodities are used in a CES function. Okay, CES function is some sort of production function, and all these are used to produce an output. So and then this output, okay, so basically what you see at the leftmost part of this graph is that there's a supply process. Some of the commodities are used as inputs, and these inputs and capital and labor actually are used also as part of the inputs, right? So these are used to produce an aggregate output. The aggregate output is the supply, and this output produced in this economy is sold to either domestic consumers, which is domestic sales, or foreigners. Okay, so when a firm in this economy engages in output in production, then the output is going to be is exported to foreigners or sold in the domestic market. Okay, and if you look at the demand side, you see that households, government, and this is the rightmost part of this graph here, the household, consumers, private consumers, government, firms, and these three actors, um, they are the main consumers in this economy. So what they do is households, firms, and government. They consume the domestically sold output. Firms are selling their output to these in the domestic market to these three actors: firms, government, and households. And these three actors, firms, government, and household, are also importing from foreigners. Okay, so this is called a composite commodity, and this is the demand side. On the left side, you see the supply side. On the left side, you see demand side. So supply and demand are connected in this way, right? So maybe one short note about firms here. Households are consuming is called household consumption. Government is government consumption, and below government use consumption you see investment and intermediate use. So investment and intermediate use are actually firms' consumption because firms are investing. Um, this is how they consume other. Uh, this is how they consume what is produced in what is sold in the goods market. Okay, for example, if a firm buys a truck, okay, basically it is used for investment purposes. The firm doesn't consume truck. Like we don't eat truck. We use it to transport our goods from the factory to maybe to the port or to the sales place or whatever. So this is investment on the firm side. Okay, so when a firm buys a truck, this is basically consumption, and but investment expenditure. Okay, and then there's intermediate use. This is also firm's consumption from other firms. And when a firm, for example, we will see later on when we talk about input-output table, if a firm is making bread, for example, and if you're buying wheat or flour, then this is some output produced by other firms. Okay, so a firm may buy from other firms for because these other products are going to be inputs for this firm, right? So this is intermediate use or intermediate inputs, if you wish. So household consumption, government consumption, investment, intermediate use, they make up the demand side of the model. Okay, the demand side, uh, what they demand, the combination of the products, goods, and services they demand, we will just name it composite commodity. Why we call it composite commodity? Because we want to use a different word other than output. Okay, so output is used for supply side of the economy. For the demand side, we just use the word composite commodity. Okay, so this is what you see in this in this slide. Basically, this is what you're going to model, which is what you're going to write in your programming code. Okay, so remember this for these slides, or when we proceed to programming later on, please refer to these slides, come back and see these again, and verify yourself that we're actually doing the right thing. Okay, now it's time to look at the input-output table. Detailed and rigorous data availability of such data has always been at the heart of economic policy evaluations. We need a consistent set of real data on the working of the economy, or just as we named it, the circular flow diagram. This is the most important requirement to start an empirical work within the CGE framework, and also it is the basic requirement for simulation exercises. So that's why at the outset we require a consistent data set in the form of a social accounting matrix as a database, and the modeling method. The modeling method we will be dealing later on. So the social accounting matrix is based on what we name input-output table. So here in this slide, we are going to look at a simple input-output table at a very, very simple hypothetical economy. An input-output table is a very useful and to put it in the right way, it's a tremendously popular and very, very powerful analytical method and tool to use in economic policy analysis. The input-output table basically presents a lot of information about the quantities in the circular flow diagram. So we have a huge amount of data in an input-output table in the form of a table, as you see in the slide. Okay, so these are actually showing such data are actually showing us the interrelations between different sectors in an economy. So one output of one sector can be an input of another sector, and many sectors might be producing their outputs using inputs from a variety of sectors. So the input-output table, a part of the input-output table, shows us such transactions. What sector is using how much input from other sectors. This might even have an important implication for policy analysis, because looking at such data, you may say something about which industry is very important for the economy and which industry is not really important for the economy. So the input-output table itself, the data itself, is important for such inferences. But the input-output provides more data than that, as we will be seeing in a minute. If you understand the input-output table, then you might have an understanding of how the economy and its sectors are actually working. So basically, the input-output table shows us the interdependencies between different sectors of an economy, and these are coming from the real-world data, not an economist's hypothetical thinking or theory behind it. So basically, it comes in the form of a matrix. In linear algebra, a matrix is a table like this with rows and columns. So if you're working with Excel, actually what Excel does is the spreadsheet in the Excel you see is also a matrix. It can be turned into a matrix. Each matrix has a row entry and a column entry. In the case of the input-output table we see here, each row here represents output of a given sector, and each column represents an input of a sector. Basically, we call this the supply side of input-output tables, or sometimes it's called supply tables. But it's not just supply, it's also use of output. So output produced can be used as a final product or as an input in the production of output of other sectors. So basically then the input-output table gives you an idea about supply and use of all the products in an economy in an aggregated form, as you see. And a little bit more about input-output tables. Also, the input-output tables also give you data about the income generated from the production activity, output activities. Okay, so overall, the input-output table shows how much of each sector's production is, and how the output from each sector is used as an input in another sector. Okay, so there are many more details about the input-output tables, but I strongly urge you to refer to a textbook on mathematical economics, or you may have some textbooks available for in your hand about input-output tables. So even a simple Google search, you will you will find out more about input-output tables. There are input-output models as well, but we are not going to spend time on that. Input-output tables, input-output models are linear algebraic models. This course does not really target such models, so we're not going to spend time on that, but don't forget that that is also available if you're interested. Now let's look at our simple economy here. This is a very simple economy, and there is only one final output, which is bread. Everything in this economy, every resource in this economy is used to produce just one product, which is bread. Okay, so all resources, the resources I'm talking about here is inputs from other sectors, and we have a bakery. In the bakery we have an owner and we have workers. So these are providing their managerial and labor services. So these are the resources we have, and all of these resources are used to produce just one thing, bread. And let's see how it is happening in this simple economy. Okay, the first thing to look at is the rows and supplies of input-output tables. Apologies for any noise. I'm outside in a park recording my class, so if you hear any voice, it's because I'm outside. Okay, so the first thing to look at, as I said, is to look at the rows and columns. Okay, let's look at the first sector we have, wheat sector. So we assume that this is a very simple economy, so you may not find it realistic, but we are just doing it to make it simple. So in our economy, wheat is produced in a field by farmers, and we assume for now that there are no inputs. We get wheat right out from soil, and just for simplicity. Okay, you may want to complicate it a bit more if you're interested, and work with numbers here. So we assume that we just get the wheat from soil as it is, and there's no cost on that. That's why in the wheat column, and if you look at the supply output part block, you see the column wheat. The wheat sector has all zeros, right? This column. Okay, so we are not getting any input from other sectors, but we are using labor. We pay farmers, and we pay also some. We also pay a little to, or more, I don't know, to the owner of the land, which is maybe the landlord, right? So we assume that all prices here are in yen. So the cost of production of wheat, so harvesting basically, costs us 100 yen. and this 100 yen goes to workers as wages and the manager or the landowner as profit. So this is the first sector we have. Okay, next let's look at the flour sector. So we are using in our simple economy, we are using all wheat produced as an input to produce flour. So wheat is not a consumption product for us. We're not consuming wheat in this economy. Wheat is completely used in the production of flour in a factory. So hence we take 100, that is the value of wheat output, which is at the total part, right? You see in the wheat column at the bottom row, you see 100 in block capital, in block letters. So this 100 now, the 100 yen worth of wheat is now completely sent to the flour factory and then used there to produce flour. And you see the flour sector is paying the wheat sector 100 yen. So this 100 there, this is the flour sector in the middle. The flour column, which is in the middle of the supply block. You see that 100 here, and this cell 100 is interpreted as follows: flour sector pays 100 yen to wheat sector. So flour uses wheat as an input. So if you go down from top down, it is a payment, and from right to left, actually, it is a receipt. So flour pays, wheat receives. Right, so this is 100. Okay, and then wheat is sent to flour factory. In the flour factory, we have again an owner of the factory, and then we have workers working there. We assume that now wages and profits in the flour factory cost us 200 yen. Now we used 100 yen worth of wheat. This is one input cost. Plus we are paying the workers and the owner of the firm 200, and that increases the cost, the value. That increases the value so far to 300. Okay, notice that the added value is 200 because 100 was already produced by wheat sector. This flour in an industry, on top of this 100 yen worth of output wheat, on top of that added value of only 200 yen, which is distributed among the workers and the owner, the manager. So now we see that there is a meaning of wages and profits. So wages and profits make up what we call value added. And another thing we get from this table is that the value of inputs plus value added makes up total supply, or the value of output. This is a very, very important equation to start with. The price of input, the value of inputs plus the value of the value added is equal to the value of output, or just simply inputs, intermediate inputs, as we name it in economics. Intermediate inputs plus value added is equal to output. Okay, don't forget this very simple but very important basic identity. Okay, so far we have two outputs, wheat, which is 100 yen, and flour, which is 300 yen. Okay, and then what we do with this flour is that because we're working on a very simple economy, now we take all the flour produced to bakery, and the bakery is using this flour and turns it into, or transforms it into bread using machines and using workers. Okay, so that's why you see 300 in the bread industries column in the supply block. You see that bread sector pays 300 to flour sector as input cost. In addition, now we are paying 200 yen to wages and profits to workers and to the manager of the firm, which now increases the output, value of output to 500 yen. Okay, so the bread industry's output is 500 yen. Okay, so far we have looked at the output of three different sectors in this economy. Well, actually the real world is much more complicated. Even with the existence of these three sectors, instead of zeros here in the supply block, you see numbers, big or small, but usually they are not zero. Okay, so maybe another thing to add here is that you might wonder, well, what is happening in this economy. Basically, we have used everything to produce just one final product, which is bread. It happens that the price of bread is equal to the value of bread, so it is 500. As you remember, we have only one final product, bread. Okay, so this 500 should be, well, this is how we define GDP. GDP is the value of the final outputs in an economy. In this case, it's 500. But you may be mistaken if you do it this way. If you add up all the outputs values here, 100, 300, and 500, you come up with a number like 900, and you may say that, well, this is GDP. Well, it is not. If you remember from your macroeconomics knowledge of macroeconomics, GDP is total value added, not total output, which means you want to avoid double counting. Double counting means that you want to deduct the value of inputs from the total value of output. Then you add up only just value added parts. In this case, the value added is in the fourth row. You see the value added section. For wheat, it is 100. For flour, it's 200. For bread, it's 200. Add up all these, you get 500, which is total value added, which means GDP. So if you see an input-output table, and if you want to calculate GDP of that country from that table, all you have to do is look at the value-added part and add up the numbers you see there. You will get the total GDP in that case. So, well, this is the supply part of the story. How about the demand side? Well, we have a knowledge about how production is happening in this economy, with a simple bread producing economy, but we don't know how consumption or demand is happening. So for that purpose, we add another block here, final demand. In this case, we have only consumption, and consumption here is on bread, because as you see, we are not consuming wheat, we are not consuming flour in this economy, because everything is used as an input of production of bread. You remember, so then consumption of bread is 500. We take the value of bread there. So this is the only way that we can use our income in this economy. Okay, this is a very, very simple economy. We are whatever income generated from whichever industry, which is total GDP in anyway in sum. So we have 500 yen available in this economy, and the only way we can use it is to spend it on the only product available, which is bread. Well, if we do not use all of wheat and all of flour as inputs, but if we use some of it for our personal consumption, then instead of the 0 here in the consumption block for wheat and flour, you may see some numbers. Okay, so but for the specific case, we are assuming that the whole economy, all production is for bread industry, going to inputs as bread industry, and the input is, and bread is the only final product, so we are consuming that. Okay, final demand here is consumption, but normally we have other components of final demand as well. This is government consumption. We don't have government here, but consumption here is consumption of households. Okay, so we may have government. In that case, we will include government consumption or government spending. Firms also consume. Remember, in the circular flow diagram, and we call such consumption expenditures investment. So household consumption, government consumption, and investment can be also other components of final demand. And remember, we also don't have any foreign sector here with no foreigners. If you want, you can add exports and imports as part of final demand too. And then you will easily realize that these consumption, investment, government spending, and trade, actually, if you add up these numbers, you also get GDP. You can calculate GDP from different perspectives. From the supply side, if you look at the table here, you just add up the value-added figures. From the demand side or expenditure side, you can just look at final demand. You will get the same thing. If you look at the numbers here, if you look at final demand, just consumption, add up all the consumption figures, you get 500. If you add up value-added figures, 100, 200, and 200 again, you also get 500. So in this final input table, there are two ways to calculate GDP. Of course, they have to yield the same number, which is 500. Alright, so now that we know about the input-output table, we can look at a real input-output table from the real world and see how it actually looks like. It's going to be a bit more complicated, but it's the whole story is very similar to what we have just done, and maybe I should spend a couple of more minutes on that just to make sure that you understand the concept and you can apply it to the real world numbers. Here's the input-output tables of the United States of America for the year 2018, which I downloaded from the BEA, Bureau of Economic Analysis, and all the figures here are expressed in billion US dollars. So let's have a close look at the input-output tables of the United States. First of all, the upper part, the supply block, as you see, includes 8 sectors, from agriculture to services. Basically, the original input-output table has more sectors, more than 200. Actually, the most disaggregated one has about 2,000 sectors, as far as I know. Here, for the purpose of just exposition, I aggregated all this data using Excel into 8 sectors. So if you look at the supply block on the left upper part, you see this in the big rectangle. You can easily follow the intermediate input demand figures. So this block shows what industry purchases what amount of input from what other industry. For example, if you look at the top left part, you see a number 106.3, which means agriculture. The agriculture sector is purchasing $106.3 billion worth of inputs from agriculture sector from itself. If you look at the next number, which is 0.2, this means that mining sector actually is paying to agriculture sector $0.2 billion for purchases of inputs. Similarly, for manufacturing, manufacturing pays $318 billion to agriculture for uses of inputs in production. So you can read all these figures this way. Just this block, the input-output table, as we name it, just this block even tells something about the structure of the economy. So in the second panel, the bottom panel, you see value added. So here value added is disaggregated into its components. In the previous simple input-output table, we just called it value added, which was made up of the sum of wages and profits. Here you can see 4 different items, and actually the sum of all of these make up what we call value added. If you look at value added, the first thing you see is wages. Actually, wages, I put wages here, but the official naming of this item in the input-output tables is remuneration of employees or compensation of employees. This includes everything paid to the employees, not only just basic salaries. This also includes bonuses. This also includes any other sort of payment made to the employees. From a production point of view, this is a cost item. So actually, this kind of calculating compensation of employees is called total cost approach. So the second item in the value added block is GOS. GOS is the gross operating surplus. This is almost like profits, although it is not perfectly equal to profits. Gross operating surplus is the amount of money available to the firm after the taxes are paid to the government and subsidies are received from the government and the wages are paid. So this is the surplus. This surplus usually refers to the share of capital. So wages are the share of labor in value added, and GOS is the share of capital used in production. So whoever owns the capital receives this amount. Depending on the sectoral structure of the economy, you can see that some sectors are receiving a large amount of payments to capital. For example, in this case, if you look at the finance industry, the share of capital is much larger than wages, and similarly in manufacturing. So, in economics, we sometimes use the word capital intensive, labor intensive production. So if you compare these figures here, wages and its share of wages and value added, share of gross operating surplus and value added, percentage shares, I mean, if you compare it with Japan or some other country, you may say something about whether America is relatively more labor intensive or more capital intensive. Or capital abundant, labor abundant. So this is, I think, what you see in international economics textbooks. So here is some values, some statistics for you to say something about that for international comparisons. Okay, and then the next item in value added is indirect taxes, but these are taxes on production, which includes also taxes on imports, which in other words, tariffs. So indirect taxes are basically value-added taxes paid by producers to the government and all other kinds of taxes payable by businesses to the government. So includes corporate taxes as well. And finally, the subsidies are included, but subsidies are not cost. Subsidies are receipts. So because value added here, wages, gross operating surplus, taxes, these are all recorded as cost items. Subsidies enter the value added here as a negative item because of this approach we're taking, the cost approach. All right, so supply and supply is made up of intermediate inputs, payments to intermediate inputs, and value added. So if you add all these up, you will get a total supply by sectors. So you can easily calculate yourself when you have time. Actually, this is not the whole picture. I took only a part of the input-output tables here. Some of the data are missing. So this is just for the purpose of exposition. On the right side, if you look at the final demand section, you see the supply part is about the supply side of the economy, right? And then final demand is about the demand side of the economy. Now we see how this production is distributed among expenditure items. So these items, expenditure items, are making up what we call final demand. Final demand is what you see in GDP. GDP is final demand is actually demand for final products, and all the expenditure items for final products make up the GDP. Similarly, for value added, you get the same thing too. If you add up all the value added by sectors, you calculate GDP from production side. If you add up all the final demand items, then you add up all these, you get GDP from the expenditure approach. All right, so if you look at final demand, you see different items. Consumption is consumption by households. We sometimes also call it private consumption. As you see, this is a large number. In a developed economy like America, um, personal consumption expenditures of households are actually making up a huge part of final demand. And government expenditures, as America has a small government, these are small. Investments, these are expenditures by firms, and if you look very carefully, some sectors have high investment figures while others are having less. For example, finance has a very small investment amount, whereas most of the investments go to manufacturing and construction, which is reasonable. And exports are also part of final demand. These are recorded in the last column of final demand section. So each of these make up are components of final demand. What I didn't include here is imports. Because import data in the United States seem to be a bit unorganized, and I didn't want to spend time on that. So if you're interested, you can take a look at that later on. So before we move on to social accounting matrix, I want to also take a look at the input-output tables of Japan in the next slide, maybe a couple of minutes on that. Here we go, the input-output tables of Japan for the year 2015. You see, input-output tables require a huge amount of data to be collected, and it is difficult to collect these data every year. And input-output tables require a large amount of data and a big number of people, staff, to compile, to arrange, and to correct any mistakes if available. So it is a big project, and that's why these data can be collected only in certain intervals. Most countries every 5 years. So you can see input-output tables for only for a period of 5 years only. So the latest one in Japan is 2015. Japan has a tradition of collecting data on input-output tables every 5 years. So this one is 2015. The next one is supposed to date 2020. I don't know whether this will be available. It will be a good idea to collect data this year because of the coronavirus, because it is unusual times, and input-output tables of an unusual time like 2020 might not be reliable. So maybe they might postpone it to 2021. Okay, having said that, I want you to also look at the input-output tables of Japan here. What I did here is, if you look at the final demand section, you will see that the domestic demand, consumption, government expenditure, investment, I added all them up to make just one consumption item, domestic demand. Basically, this is a good way to actually analyze the economy. If you look at consumption, government expenditure, and investment, these are all domestic actors, and domestic households, domestic government. I mean, government is also domestic, right? And domestic firms. All of their expenditure items in macroeconomics. This is C plus G plus I. This is domestic demand. Exports are foreign demand. These are for demand of foreigners for our products. So domestic demand plus foreign demand minus imports, which is our demand for foreign products, is GDP again. If you add all these up, you get GDP. Notice the zeros in exports and imports items, export and import rows for construction. So construction doesn't, this sector doesn't engage in export and imports, while these such sectors are called non-tradable. But all others trading some amount, these are tradable sectors. Okay, if you look at imports column, you will see minus, because imports are payment to outside. These are payment to foreign products, not domestic products. Input-output tables are about domestic production, domestic products domestically produced. Okay, because of that, we are calculating GDP, which is gross domestic product. Whoever is producing in this country, in the case of this table, this is Japan. It might be a foreign company, it might be a Japanese company, but if it is happening within Japan, within the borders of Japan, then this is a part of a Japanese GDP or Japanese domestic production. So input-output tables do not they do not usually distinguish between between production, most often manufacturing, by foreign firms or Japanese firms. Also services. A lot of services sectors have been investing in Japan lately, such as software companies. This is included in the services sector. And I actually put two services out of the services sector and put them separately here, which is ICT and finance. ICT is information and communications technologies, and finance is, banking and insurance and all other kinds of financial institutions. So you might wonder, what kind of an economic structure Japan has. If you calculate the share of each of these sectors, you see here I put 7 sectors: agriculture, energy, construction, manufacturing, ICT, finance, services. If you calculate the shares of everything you see in total output or total supply, then you may say something about the structure of this economy. And if you look at the supply and the intermediate input block, which is the upper left part of upper left block, you can easily say something about what industries are buying what amount of inputs from what other sectors. For example, if you look at manufacturing is basically buying inputs from itself. You will see a number like 133 so it's $1 trillion, trillion yen. So 133 trillion yen in manufacturing is paid to the manufacturing itself across the manufacturing industries as intermediate inputs. So this might be purchases of chemicals by the electronics industry, or purchases of automobile from manufacturing, other manufacturing sectors, and etc. So I aggregated all these up here. If you are interested in disaggregated figures, I put the link here. You can check out the input-output tables of Japan, or I made it short here, IO tables of Japan for 107 sectors. If you're specifically interested in automobile industry, then you might want to check out those figures. Okay, so you will see a much more detailed and much bigger input-output table there. So you're free to do that in your own time. All right. Let's also look at the value-added block here: wages, gross operating surplus, indirect taxes, less subsidies. The same type of a presentation like in the previous slide. What you will observe here is some sectors here might be more labor intensive, and some others may be more capital intensive. To calculate capital intensity, all you have to do is divide the GOS, which is gross operating surplus, the share of capital, and this you just divide it by total value added. Okay, so it is very important here to note that the input-output tables, as you see in the case of Japan in this slide, they also have a very important meaning. So in economics, the way resources are organized to produce something, or the way factors of production are organized for the purpose of production, is called technology.
So we have here all the resources included. One resource is inputs from other sectors, which is the intermediate inputs block, those numbers you see there. Another one, well, these figures, 1,569 in the case of agriculture to agriculture. Well, in this case, agriculture and mining together in Japan, because mining is a very small sector. I combined it with agriculture, and from agriculture to energy as payment of inputs, 168, and so on. So this is one of the resources we use. One of the factors. This is not a factor of production, but this is an input we use in production. But the factors of production are workers, labor, capital. Okay, so we are using here inputs from other sectors, labor, and capital. Capital is the machines and all the industrial facilities we are using in production. Okay, so what we do here is in the input-output tables is that if you look at the supply-output columns, in the end you will see total supply, right? In the final, the last row, and you can calculate the value of output by each sector in this row. This is basically the column sum. So in the case of agriculture and mining sector, you see that 13 trillion and 717 billion yen, which is the sum of all the figures starting from 1,569 down to minus 755, right? So this is basically how technology. This is basically the technology of agriculture mining sector. So in this agriculture mining sector, part of this payments, the cost of production in this sector is 13 trillion and 717 billion yen. All right. So out of this total cost of production is also the value of output. Okay, so the total cost of production, if you see, is now distributed to inputs, wages to workers, labor, and payments to capital, which is gross operating surplus, GOS, for capital services. But remember, also the taxes are also a cost item, which is included in value added. And finally, when this sector receives subsidies from the government, it is also included, okay, as a negative cost item, as I mentioned before. So in the case of Japan, if you look very carefully, you will see that agriculture mining sector receives a lot of subsidies from the government in the amount of 755 billion Japanese yen, which is quite a large number. So this is basically technology, and we refer to such a way of viewing technology. We name it after the original founder of the input-output tables, a Russian-born American economist, Vasily Leontiev. This way of depicting, this way of portraying the technology of production is called Leontiev production, and this itself is a production function, which shows you how production costs are distributed to production factors and inputs. And you know that this data is for 1 year, okay, and then that means these are fixed. Until you collect the next data in the next maybe 5 years later, we assume that from this year to the next time we calculate these figures again, we collect this data again for the next for the 5-year period that we have data, we assume that this technology is not changing, so fixed, and these figures will be the structure of the economy. These numbers may change because of the inflation or so, but what we will observe for the 5 years, or what we will assume for the 5 years, is that the composition, the percentage composition of inputs and value added as a percentage of course, total supply will not be changing. This is what we assume because we don't have data, and we will not have data for another 5 years. In the case of Japan, we will just assume that this technology has not changed will not be changing for the next 5 years, which is not very unrealistic because technology doesn't change so quickly. So for 5 years, we may say that, well, this is a very reasonable assumption. All right. The Leontief technology function says that the inputs, the share of inputs in the production cost or cost of production is not changing. Later on, when we discuss about the production functions, we will mention Leontief function again. Okay, when we discuss Leontief function, please remember what we said about input-output tables here. So it is very, very important to note that the input-output tables, they carry a very meaningful amount of data, and this is what we need because what we want to do in CGE modeling is we want to model the working of the economy, and here's a very, very simple way to understand that. Okay, if you're interested in the relations between different sectors, well, even a very aggregated form of input-output tables, just like you see here, will be enough. So you can say something about the economy, and you might want to even do some analysis on your own. Okay, so one final thing about the input-output tables I want to mention before moving on to social accounting matrix is that if you look at the column sum and row sum, you will see that they are equal to each other. So for the agriculture and mining sector, the total supply, which is the column sum, is 13,717 billion yen. If you look at the row sum, which is to the far right up, you will see the same figure. And similarly for all other sectors, which means total supply is equal to total output, which is reasonable. This is what we said about the conservation of value at the beginning. Okay, so if you want to put it in another way, please check out the equation what I put under this table. So total supply equals intermediate inputs plus value added. And because total supply equals total output is equal to intermediate inputs or input demand plus final demand. So input demand plus final demand from the demand side, you will see that this equals total output. So in other words, you may say that intermediate inputs plus government consumption, household consumption, investment, exports minus imports is equal to total output. Or put more simply, GDP plus intermediate inputs is equal to total output. So what we see in statistics is GDP. GDP is the sum of all final demand you see here. If you're interested and if you want to test your knowledge of how well you understood the GDP and output concepts, you might want to check out that GDP in Japan, in this input-output table, you can easily calculate GDP equals 548 trillion and 219 billion Japanese yen. So please do the calculation on your own and try to get the same number. You can easily calculate the from the this is from the final demand. You can also calculate it from the value added side. All the value addeds should also add up to GDP. You will see that there's a very small difference here because of the rounding up. You did it on Excel, so that may be very small, very small, minor discrepancy, but this is not important for the moment. Okay, so let's now finish our discussion of the input-output table. This is the first half of this first lecture. This first lecture is for 2 weeks, and we will move from input-output tables to social accounting matrix. The social accounting matrix is built on input-output tables, in a different form. But the ideas will be very similar, and you will find it easy to follow. So what I want to do is I want to follow the textbook, Hosoe and others. They start with a very simple SAM, a hypothetical SAM. Instead of working with real data like we see here in this slide, let's start from a very simple, very simple hypothetical social accounting matrix, and just work on that, and step by step develop our own social accounting matrix. Once we are done with social accounting matrix, we will be ready to discuss the structure of a CGE model. And then the CGE model is going to be just a numerical or algebraic explanations of what you see as relationships in the social accounting matrix. In a way, social accounting matrix is an extended input-output table. So I think so far we have taken a long way to understand what CG modeling does by first understanding the interrelations between different sectors in the economy. So we will be moving to SAM in a short while.